Hello, my name is Brian Summers, and in this video I'm going to walk you through a brief introduction to Isilon's ScaleOut NAS. Before we get too far, make sure you take note of the related Isilon resources here. These are posted in the description of the video. The Isilon weekly link can be used to register for a live weekly presentation. It'll be this presentation that you'll see here along with a live demo. The playlist link, the Isilon playlist link, will take you to a recorded on-demand version of this presentation as well as the demo on YouTube. And then the simulator download and the hardware Gen 6 link are for those of you who are big nerds just like me and just really want to spin your propeller and get your hands on Isilon and see exactly how it works. So feel free to check all those out. Again, those are posted in the description of this video. The agenda for the presentation here is as follows. We're first going to start by understanding where Isilon fits in, specifically within the very broad Dell EMC storage portfolio. So we'll knock that out right up front because that's one of the most common questions I get. Second thing we'll talk about is Isilon's business momentum. Been around since 2001, so we'll see how we've been doing. And then the last three bullet points all kind of go together, and they're really to understand fundamentally what makes Isilon different and what it's good for, and how it helps people keep up with the growth of their unstructured data, and really simplify the day-to-day management of all this data that's growing out of control. So that's the presentation. Let's dive in. For starters, what you're looking at here is the entire Dell EMC storage portfolio as it stands today. So it's a very large one, and a lot of times it can be challenging to understand exactly what products are for what, and that sort of thing. So to simplify things for this discussion, Isilon is a NAS platform. So if you boil our entire portfolio down to the three NAS offerings we have, then the discussion becomes much simpler. So if you understand what a NAS is versus other traditional storage platforms, then right off the bat, you understand Isilon is a NAS. More importantly, though, our NAS portfolio breaks down into two types of NAS offerings. There's the ScaleUp approach, which is our traditional NX series based on Windows storage server, that sort of thing. We have our FS series, which is really good for our customers who've already made a big investment in Compellent. But if you're looking for a standalone NAS that can keep up with the massive scale and growth of data nowadays, that takes a ScaleOut approach instead of a ScaleUp approach, then Isilon's really the only thing in the portfolio. So we'll talk in great detail about scaling up versus out here in a bit, but hopefully that helps right off the bat level set with where does Isilon fit in the portfolio, how is it different than a lot of the other offerings, etc. So the last thought I'll give you here is that all the offerings you see here that are faded out, those are all block storage offerings or backup offerings. So with block storage, with those things, you're going to present volumes or LUNs to host and do that sort of thing. With a NAS, fundamentally, you're presenting files and folders to the environment instead of LUNs and volumes. So it's a NAS platform presenting files and folders and not a block platform presenting volumes and LUNs and that sort of thing. So we'll focus on Isilon for the rest of the presentation, but hopefully that gives you a good feel for where this offering fits within the broader portfolio. So let's talk a little bit about traditional ScaleUp versus ScaleOut and that fundamental concept. With traditional ScaleUp approaches, you're used to things like RAID. Which RAID type do I need? LUNs. How many LUNs do I need to create? How many disks should be in that group? HBAs, how am I going to connect these things to host servers and different operating systems? All these different things that really go into being an expert with storage. And the key thing here with Isilon is none of this matters. As an Isilon admin, you won't deal with RAID because we don't use it. You won't deal with LUNs because you just don't create them. You won't deal with hot spares and snapshot reserves and all these other things. So we'll talk more in depth later in the presentation about what we do instead of RAID and some other things. But right off the bat, I wanted to make sure that everyone's clear that why Isilon? The answer to that question is a lot of this complexity can just literally be thrown out the window on a day-to-day basis. So as far as Isilon's business momentum is concerned, we've been around since 2001. And the reason for our success is our software. And our software is called OneFS, and that just means one file system. So another very common question I get is, what is Isilon? And that's the answer. It's one file system for any customer's environment that can be used to store files that can then be accessed by Windows, Linux, Mac, any operating system that speaks traditional file protocols. We'll talk more about what those are as we go. But at the end of the day, OneFS is the reason for our success. And it's why we ship exabytes of storage every year. It's the reason that we're number one in the ScaleOut NAS market. OneFS is the reason we've got almost 10,000 customers, and we still see double-digit revenue growth, even though we've been around since 2001. So whether you talk to analysts like Gartner or any of our 10,000 customers, almost 10,000, OneFS is the differentiator. It's what makes us a better product than really anything else on the planet. So let's talk now, let's put my engineering hat on and talk more specifically about what kinds of data are well suited on an Isilon platform. Because even though we're the best at what we do, there's some data that you just would not put on an Isilon. So let's talk about that. So traditionally, if you've ever deployed a server, then you know that whether it's Windows or Linux, you separate these two things. You put the OS and the application on one partition, and the data that gets generated by that application, you put on another partition. So the question here is, why do we do that? And the answer is pretty simple. The structured data, which is what I'm pointing out here with the OS and the app, tends to be very low capacity. So it doesn't take up a lot of space, whereas the data being generated by that app tends to take up more and more space every day. I have yet to talk to a customer in the last 20 years who says their app is not generating more data. The OS and the app over there on the left, the structured data is also very predictable. So once you deploy an OS and an app, it's kind of a fixed amount of capacity that it requires, and its performance requirements are also very predictable, whereas the data being generated usually is very unpredictable. So while every customer tells me without fail that they have more data every day, they struggle to tell me how much more they're going to have in a month or 6 months or 5 years. So it's very unpredictable on the unstructured side of the house. And then the third thing that's important here is the way in which that data is accessed. So an OS and an application tend to require very transactional access. So you think a database, for example. You need very low latency, you need super high performance, a small amount of SSD would be perfect there. Whereas the data being generated by those apps, often PDFs, maybe video files, audio recordings, PowerPoints, whatever those might be, those are very non-transactional. So often that data gets written out to storage and then very rarely gets accessed after that. So non-transactional. So you got these two very different types of data, structured and unstructured. So where I'm going with this is the structured data is very well suited on a block storage platform, like we mentioned earlier when we looked at the Dell EMC portfolio. So those block storage platforms are great for storing virtual machines, for example. And the analogy I like to use for those is those block storage platforms are a lot like the kitchen cabinet, right? It's not a lot of space in there. There's just enough space for what you need. And everything is very well organized. The big plates go here, the little plates go there, etc. So it deals well with transactional access. When somebody wants to go get a dish from the kitchen cabinet, it's not a process, right? You just open the door, grab your dish, and you get out, right? Not very difficult to do that. And then as you get more dishes, if you will, you just put them where they're supposed to go. And things stay nice and organized and isolated from one another. You don't have to worry about reaching in for a big plate and finding a cup, because everything's where it's supposed to be. File storage, on the other hand, is ideal for unstructured data because it is the opposite of that structured data in every way. It's high capacity, it's unpredictable, and it's not very transactional. Very rarely do you have people coming and going. So it's kind of like the obligatory teenager's bedroom. So a bunch of stuff in there, not many people are accessing it. Some of that stuff's been sitting there for years. But if I go look at it today and look at it a month from now, I might see two totally different things because things have moved around and it's not quite as well organized and structured as the virtual machines on the left. So it's the unstructured data that's very well suited on file storage that we're talking about with Isilon. So that data grows, sometimes shrinks. Point is, it changes and it's very unpredictable. So to drive the point home here, the block storage stuff is really suited for storing virtual machines or maybe even physical machines. The point is the OS or the application. Whereas a file storage platform is more for the D drive. So Isilon, not well suited for traditional block storage workloads. Isilon is very well suited for unstructured data, so the non-C drives in your environment. So that begs the question, how do I quickly take a look at my environment to understand how much capacity is being consumed by my structured data and how much capacity is being consumed by my unstructured data? And more importantly, what are the performance requirements around those two data sets? So we have a free tool here called Live Optics. And the way Live Optics works is we point it at any customer's environment. And it's the virtual equivalent to taking maybe a college student or some really cheap labor and saying, go to every one of my machines and go to the performance monitor window and tell me how much capacity is being used and how much is on the C drive and what are my drives, and doing all that detailed inventory. But Live Optics does that in an automated fashion. So we go scan the environment, and what we do is we start by scanning the environment with a tool called Live Optics. Live Optics is sort of the initial reconnaissance. So we'll go look at the environment and find out where is the unstructured data, how much of it is there, how much of it's actually moving around the network, etc. So just sort of get a baseline of what's what. Now that we know where things are, we can dig deeper into what that data really is. What are the file size distributions? How frequently are those things accessed? Potential for archive, that sort of thing. And we use a tool called Dossier for that. So with Live Optics, it's a two-pronged approach. We do an initial reconnaissance run, if you will, with optical prime. And then once we understand where the data is, we do a little deeper dive with another tool called Dossier. Both of them fall into the Live Optics tool set. So check that out. Once we understand where the data is, then it's what we find most of the time is that the unstructured data, not only is there more of it than the structured data, but it's also growing at a much faster rate. So once we learn that from the Live Optics collections, it's then important to understand how traditional ScaleUp NAS deals with that data growth. So if you're looking at a traditional ScaleUp NAS offering, what people have done for years is they put a head unit in place with a tray of disk. So the analogy here is that head unit or that filer is a horse, because that provides all the horsepower. So the compute, the networking, the RAID, all that good jazz. And the cart here would be analogous to the tray of disk. So that's your storage. So this is traditional ScaleUp NAS. And if you don't have data that's growing very much, this is perfectly fine. Nothing wrong with this setup. But if your data is growing a lot, then what we find people doing every 3 to 5 years is we'll have to throw out that horse every few years because I need to add another cart, and that horse isn't big enough to pull 2 carts. So I throw out the horse, I get a bigger horse, now I have 2 carts, and life is good. But the reality of that situation is that can be a very painful process for customers because you have to schedule downtime, you have to manually migrate data between those 2 carts, and there's a lot of manual work that goes in there, especially in larger, more complex environments that can cause serious business issues. But that's the way things have been done. It's the traditional approach. So what we see is, again, they'll do it again 3 or 4 years later. They'll throw out that horse, they'll get another bigger horse, they'll add more storage. With Isilon, we're more of a modern scale-out NAS approach. So continuing with the horse analogy, we still start with some horsepower and some amount of storage. But rather than adding more carts, we just add more horses. So you add another node, or server if you will, and each one of those servers has some amount of compute, networking, data protection, and of course hard drives or spindles. But logically what we present to the environment is one bucket, one storage. So instead of seeing these different silos, you have one big namespace that everybody can continue to access. And you can add and remove nodes, i.e. horses, non-disruptively without taking users offline. So to sum it up here, with traditional scale-up NAS, you replace your old horse every few years, which can be a very disruptive process. With modern scale-out NAS, you add and remove those horses as you need them. With the traditional approach, you're only as fast as your newest horse or the newest controller. With the scale-out approach, every time you add more horses, of course you're adding more capacity, but you're also adding more performance. So you never run into a situation where you're only as fast as your newest horse. And then the third thing here is that traditional scale-up architecture can be very disruptive anytime you need to change anything about the configuration. If you need to migrate data to a new volume, you need to resize things, it can be a very tedious manual process. Whereas those sorts of things are non-disruptive and don't impact users on the ScaleOut NAS side. Then the last bullet point here, the traditional approach, you end up with those multiple buckets of storage or multiple silos, whereas with the modern ScaleOut approach with Isilon, you have a single bucket of storage, so one namespace, one file system. So that's the quick summary. The traditional scale-up NAS is more of our, we have some legacy products in our portfolio that take that approach still. We also have some competitors that use that approach. But where we're headed with Isilon is more the modern scale-out approach. And like I said, we've been doing that since 2001, so we're not new to that game. And we're really as good as it gets when it comes to a modern scale-out NAS architecture. There are a few others out there that are similar architectures, but they're more build-it-yourself, community support kind of things, whereas Isilon is a well-polished, commercial-ready offering for a scale-out NAS. So let's take a closer look at the actual topology. What does this look like when you put it into a customer's environment? So as we said earlier, all of our customers have some combination of Windows, Linux, or Mac machines. Those machines are all speaking to a couple of switches, so some number of switches, so that they can all talk to each other. And the languages they're using, or the protocols, are file protocols. So two Windows machines are going to talk to each other with the SMB protocol. Two Linux machines probably going to communicate with an NFS mount. Most Mac machines are going to use either SMB or CIFS, might also use NFS. But the point here is, regardless of what OS is on the left, these are the protocols they've been using for decades now. So these are not new. Some of them are new though. You have HDFS and Swift and some of the more modern protocols that are coming into play. So what Isilon does is we say, if that's what everyone's already doing, then what we're going to do is we're going to put one file system in the environment. We're going to connect into that network, and we're going to speak those file protocols. What we're not going to do is we're not going to speak proprietary protocols like iSCSI and Fiber Channel that require a lot of expertise and technical knowledge to make that work. So we're going to speak those file protocols, and we're going to present one file system, one set of files and folders that all clients on the left can access. So whether you're Windows, Linux, or Mac, everybody gets to access that top-level directory. Everybody gets to access any of the subdirectories. Everybody can simultaneously access any of the files. So at the end of the day, we're presenting one file system that everybody can access, provided that the admin has given permissions to do so. So of course there is control over that data as well. And the reason we're able to make that work is, one, our software, OneFS, it lives across all those servers that you see there. So in this example, we've got 4 servers, but we have one file system striped across them all. And then of course we also have a couple back-end switches, so those different nodes can talk to each other. So going back to my horse analogy, I've got 4 horses here, but one big bucket, one big namespace. But I have the horsepower of 4 servers serving up that data to my users. So that's a 30,000 foot view of the actual topology and what Isilon looks like within a customer's environment. So let's take that same 4 node example. Here I've got those same 4 nodes. I've got one file system that lives across all 4. So I've got a 4 node Isilon cluster here. So again, going back to my analogy, I got 4 horses, but one big namespace, one big file system. Over time though, I start to accumulate more and more data, because that's what data does. So I add additional nodes that might have more capacity but less performance capability. So now at this point I've got 8 nodes. In a traditional storage approach, 1 or 2 of these servers would be the controller, and the rest of them would just be trays of disks. With Isilon though, every single one of those 8 nodes has CPU. They all have network connections into the LAN. They all have RAM. They all provide horsepower. They all participate in serving up the data to the users. And what I'm showing you here are 2 examples in our Gen 5 hardware portfolio. Our larger nodes for archiving and our smaller nodes for performance. all acting as one big namespace. And the way this works is you can add as many as 144 nodes into one namespace. And the minimum starting point with Isilon with Gen 5 is a 20 terabyte usable capacity. So if you want to start somewhere in that 20, 30 terabyte range, Gen 5 is probably where you want to start. We offer this today, and we probably will offer this for the foreseeable future. Also, it's important to note that for the client connections that want to get data from the cluster or send data to the cluster, we support 1 and 10 gigabit Ethernet on that front-end network that we talked about earlier. Now, the future of Isilon hardware, it really looks more like this, though. So we've got Isilon Gen 6 that we rolled out about a year ago. It starts around 90 terabytes usable. So, of course, there's a big gap there between 20 and 90. So, again, if you're looking to start in the lower end, 20, 30 terabytes, probably want to consider Gen 5. If you think that you're going to be in the 40, 50, 60 terabyte range, or that you're going to grow to 90 or beyond in the relatively near future, then you probably want to look at Gen 6. And it's also important to note that Gen 6 supports 10 gig, just like Gen 5 does, but it does not support 1 gig. So with Gen 6, you're going to be using either 10 gigabit Ethernet or 40 gigabit Ethernet to connect to those clients on the front end. And most important thing to note is that one box there has 4 nodes inside it. So you have 4 fully functional servers inside that 4U chassis, 4U enclosure. And then you can have as many as 120 drives in there. So with Gen 6, we're getting a lot more done in a lot less space with a lot more horsepower. But the good news is, whether you're Gen 5 or 6, you can, of course, mix those together and continue to have one big namespace. So in this example, what we're looking at here is 12 nodes across 2 generations of hardware with still one single file system and the ability to add and remove nodes at any time in a way that's non-impactful. So you don't disrupt users to add or remove nodes. You simply do that on the back end, and the namespace gets larger or smaller depending on if you add or remove nodes. So this is very important to customers who want to keep up with a lot of data growth, but don't want to deal with that traditional pain of scale-up NAS architectures where you need to take things offline every few years to go get a new horse. So that's it for the presentation part. Check out the second video where I'll go through a live demo. In that demo, we'll do these activities that you see here. We'll access the cluster to demonstrate our multi-protocol access, the ability to access it through SMB, through web protocols, that sort of thing. We'll see how to provision storage. It's a feature we call smart quotas. So maybe you want to set aside a certain amount of storage for all your home directories, or maybe you've got a video surveillance project where you need to set aside some amount of storage for your video servers, whatever that might be. We use smart quotas to provision that storage. We'll then review the protection level options. We'll take a look at something called erasure coding. So that's what we do instead of RAID. So that's what allows us to scale as far as we do from terabytes into the petabytes. And what allows us to do that non-disruptively. And then we'll also take a look at how we deal with protecting against human errors. So how do we do snapshots? How do we create snapshot schedules, etc.? What are the retention periods? And we'll see how we can also replicate those snapshots to a secondary cluster with a feature called SyncIQ. And we'll talk a little bit about how we integrate with more traditional backups with NDMP and that sort of thing. And then lastly, in the demo, what I always cover is what it looks like to add a node to a cluster. And I do that live so that you can see that that takes about 60 seconds. And it's quick and easy to do. So that's what you can expect in the demo. But that's it for the presentation, and I'll leave you with these reminders here. Check out these Isilon related resources. You got the weekly link there if you want to register for a weekly live demo. The Isilon playlist includes this video that you're watching, along with a second video where I go through the live demo. The third link and beyond, so from the simulator to the OneFS admin link to the Gen 5 and Gen 6 hardware links. Those are really, like I said, for the nerds in the audience like me who just really want to geek out, get your hands on a simulator and really understand exactly how this thing works from an admin perspective. So that's all I've got for you. I appreciate your time and have a great day.